Hey everyone, today I'm going to go over how to integrate Bazel with Python and how to make your builds reproducible. So what exactly does this mean? I have a Python script here. It has NumPy, it has SciPy, and it does some linear regression. I haven't yet installed NumPy or SciPy on my machine. Additionally, if I send this to someone, they might have a different version of Python. They might be using Python 2, and their script might not behave the same way. Now, if I use a build system, something like Bazel, which is very easy to set up, I can ensure that anyone who clones my repo and tries to run this script will run it in the exact same manner because all of the inputs are described explicitly by the build system. So we're first going to start by creating a new module.bazel file. And we're going to go to the Bazel Central Registry and find rules Python. Let's put that in here. Now, next, we need to describe the inputs we need for NumPy. So we're going to create two new files, a requirements.in and a requirements.txt. In the requirements.in file, we're going to write NumPy and SciPy. Cool. Now let's create a new file called build.bazel. So this tells Bazel the things we want to build. Now we're going to go to the rules Python docs, and we're going to go over to this Python pip part, and we're going to add the compile pip requirements rule. So let's do load rules Python pip.bzl compile pip requirements name, we'll call it rex requirements in requirements.in requirements txt equals requirements.txt. Now let's run bazel run rex.update. Now this populates our requirements lock file. Now let's go to the rules Python main readme and let's install pip. So in our module.bazel file, we're going to install pip from requirements.txt. Let's just call it pip. Now, in order to create build files for our analyzer.py, we need to first create an init.py. It can be empty. Let's save it. And we want to generate build files. So we can do this by using the Gazelle Python extension. Let's first go look at the Gazelle Python README docs. And we need to first install a manifest. So let's go back to the central registry. Let's get Gazelle. And let's get Python Gazelle. Now, we want to copy the contents to create our Gazelle Python.yaml manifest into our build file. We don't need this bottom part. And our requirements file is actually called a requirements.txt. Then we also need to create a Gazelle Python.yaml file. Now that we have our Gazelle Python manifest, let's run Bazel run Gazelle Python manifest.update. Nice. Now our Gazelle Python file was created, which tells Gazelle how to update it. Now we're going to actually create the Gazelle binary. So let's go to our build.bazel file and create the Gazelle binary. This is also from the Gazelle docs. Here we actually call Gazelle just Gazelle, not Bazel Gazelle. So let's run Bazel run Gazelle. And so what this has done is this has generated a build file for our Py binary, our Py library. You'll notice that your file actually has to be differently named than your directory. Otherwise, these two will clash. But the deps are properly loaded and correctly reference the NumPy and the SciPy downloaded in the requirements lock file. So now let's go ahead and run our tool. So Bazel run tools analyzer analyze. Awesome. So everything works as expected, and you can give this to anyone else. They can clone the repo, and they will get the exact same result as you because they're running with the exact same version of Python, Python 3.11, and they have the exact same requirements lock file. Thanks for watching.